All right, welcome back to the fourth and final page of the Unit 5 final exam review. On this page, we're going to look at solving trigonometric equations, especially with double angles, and then we're going to look a little bit more with double angles. So for number 23, we have a double angle equation. We have sine of 2x equals tangent of x. I notice here that that's an identity, so I'm going to use my identity sheet, and I'm going to change that right away to 2 sine x cosine x, something that's a little bit easier to work with. Okay. When solving equations, we want to isolate the variable. So we want to get everything on one side. So what I might do first is I might change this to sine over cosine before I move it to the other side. Regardless, I'm going to have to try and combine those with like denominators. So I might as well get rid of this denominator now by multiplying both sides by cosine of x. So I have 2 sine x cosine squared x equals sine x. Then we can go ahead and subtract. And then you'll notice that we have a sine in both of those. When I take out a sine, I'm left with 2 cosine squared x. Don't forget, I still have a minus 1 here. Okay, if I set each one equal to 0, I'm left with sine x equals 0. Here, if I add 1 and divide by 2, I'm left with cosine squared x equals 1/2. But then I want to take the square root. Reminder, when you take the square root, you need to have plus or minus. So you end up getting cosine squared equals plus or minus square root of 1 is 1 over root 2. This is the same thing as plus or minus root 2 over 2. Okay, so once you've isolated the variable, you're going to look on the unit circle at where this happens. So where is sine of x equal to 0? Remember, sine is the y coordinate. When is the y coordinate equal to 0? At 0 and at pi. All right, over here, for cosine of x equals plus or minus root 2 over 2, cosine is the x variable. That happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so all 6 of those answers work for this problem. Okay, so that was definitely one of the longer ones. You had an identity, you had a factoring, and then you had multiple things you had to look for on the unit circle. Okay, for number 24, I noticed that I have a cosine in both of those. So I can factor out a cosine x, and I'm left with cosine x plus 1. If I set each one equal to 0, I get cosine x equals 0 and cosine x equals -1. Looking on the unit circle, again, cosine is the x of the ordered pair. Where do I have a cosine equal to 0? That is at pi over 2 and 3 pi over 2. And then where do I have an x value, cosine of -1? That's at pi. Okay, so all 3 of those answers work for that problem. Okay. All right, so for these last three here, I already have the picture drawn. So it said if sine of x equals 12 over 13, and x is an angle in quadrant 2, find each value. Okay, so again, I already drew the picture sine opposite over hypotenuse, where it's in the quadrant 2, like it asked for. I'm going to find that missing side to start. Okay, so using Pythagorean theorem, I get 5. But since that's in quadrant 2, I know my x values are negative. So that is a negative 5. Okay. For number 25, you actually have 3 different choices. If you look on your identity sheet, whichever one you choose to use is fine. I am going to use the identity 2 cosine squared x minus 1. All right, so now what is my cosine there? My cosine is negative 5 over 13. If I square that, I get 25 over 169. And then multiply, I get 50. And I'm going to change this to 169 over 169. And that ends up giving me a negative 119 over 169. Okay. For sine of 2x, that is the same thing as 2 sine x cosine x. And then I'm just going to use that picture and fill in. So I know my sine is 12 over 13. My cosine is negative 5 over 13. And if I multiply straight across, I end up getting negative 120 over 169. All right, and then finally, tangent of 2x, I'm going to change that to 2 tangent x over 1 minus tangent squared x. Again, all of these are coming straight from my identity sheet. Okay, so 2, my tangent here is 12 over negative 5. And I'm just going to plug that right in. So on the top, I end up getting 24 over negative 5. Okay, this here becomes 144 over 25. Okay, which is 25. This is 25 over 25. So when I subtract, I get negative 119 over 25. Oops. Okay, and I can rewrite that with multiplication. So if I multiply, okay, and I can do some crossing out here. That gives me a 5. Oops, divide both by 5. Negative times a negative is going to be positive. And I'm left with 120 over 119. Okay. And that concludes your Unit 5 final exam review. Good luck on